Hey everyone, thank you for joining us today on what promises to be a fascinating discussion on privacy enabling blockchains and their challenges. Privacy is often talked about as a core principle in blockchain, but it's never kind of realized in the way that we want, which is scalable, secure, compliant, and even one of the core principles of the Web3 ecosystem is being transparent. So we're here with this amazing panel of experts to talk about what is the challenges that occur in building privacy-enabling blockchains. So we have Zack from Aleo. Hi, Zack.
Hello, hello.
Adam from Aleph 0.
Hello.
We have Zain from Horizen Labs.
Hey, everyone.
And Rahul from Aztec.
GM.
So I can't wait to hear all of your insights on this. But before we start, I'd just like to go around and have you introduce yourself, what you're doing at your various respective protocols, and what the protocol does as well.
I'll start. I'm Zack, an engineer at Aleo. I was building a wallet on top of Aleo before. And at Aleo, we're building a layer 1 blockchain. It's actually live on mainnet now, and it's the first private programmable blockchain. We don't need to clap every time.
Hey, so I'm Adam. I'm a cryptographer and one of the co-founders of Aleph 0. And right now we focus mostly on building a privacy hub for EVM, which is actually a universal privacy pool for interchain operations. And we think about it as a universal wallet, and our main front end for it will be wallet kind of front end.
Thank you.
Hey, everyone. I'm Zain, CTO of Horizen Labs. At Horizen Labs, we're builders on 2 platforms. One is Horizen, which is an L1 blockchain that is home to the Zain cryptocurrency. It started out as a fork to Zcash, so it was a privacy coin. And then the other platform is called ZK Verify, also an L1 blockchain solely focused on proof verification.
Hi everyone, I'm Rahul. I'm a senior PM at Aztec. I'm leading our testnet. Aztec is a privacy preserving layer 2 on Ethereum, since there are L2s on Solana as well. We are aiming to launch fully decentralized on day 1, which is something no L2 has done. Excited to dive deeper.
Amazing. So inspired by the talent here. Let's start by looking at the big picture. So blockchain's core principle, one of the core principles of blockchain is having transparency, right? There's no centralized entity controlling anything, and anyone can audit what happens on the blockchain. But it's always at tension with when you want to bring privacy. How do you get privacy and blockchain in the same in the same system, right? So how do you guys view this tension, and what does the state-of-the-art technologies do to kind of balance these 2 concepts? Zack, why don't we start with you?
Yep, so I mean, how we view it is that if you want to have payments and actual use cases that we use every day, or businesses transacting with stable coins, or voting systems adopting blockchain technology for the cryptographic verification it offers, you have to have some form of privacy. The internet started without it, then it adopted TLS, SSL, you had HTTPS, and so that's what we want to introduce for the blockchain realm. And to get to the technical level of how we do that, we use a technology called zero-knowledge cryptography, zero-knowledge proofs, and that's basically, I can prove something to someone without revealing the underlying information. For example, I want to prove I'm older than 18, but I don't want to reveal my date of birth. And that's a very simple example. And you can think of that for transactions on a blockchain, if you push the computation of the transaction to happen on a user's device, like their phone or their laptop, and they generate a proof that they ran this code correctly, then they only have to put the proof on the network stored on the transparent ledger that we're talking about, and the inputs and outputs to that function, and you encrypt those. And so via zero-knowledge proofs and encryption, you achieve privacy in a transparent realm. That's how it's done.
Adam, what's your take?
I mean, there's a question where actually I think most of us have similar takes, so maybe I'll just try to extend the previous opinion. So, yeah, I mean, that was a very good explanation of how it is actually done. What is often asked is, like, why do we want privacy on blockchain? So I think this is in a way incorrectly posed question. I mean, we do have non-private blockchains now, not because someone wanted non-private blockchains, but because of technical limitations over times where the blockchains were invented. So it's not like this is the universally good thing to have non-private transactions. No, this is actually very weird. And if the blockchains would be designed with only features on mind, not caring about the technical limitations, surely they would have privacy from day zero. So, like what we see the privacy movement is trying to achieve is that it's trying to achieve this obvious feature base that the blockchain should have from the get-go, and they just didn't because that's hard. So, yeah, that's my take. Thank you.
Zain, anything to add?
No, Adam's said it really well. Yeah, I feel like, I mean, for me, privacy and transparency are, yeah, two sides of the same coin where you want to be transparent with what you're doing in a way that still retains that privacy. Privacy is this fundamental right for all of us. I studied computer science and also was very interested in psychology. And it was very interesting to me where, you know, in our physical lives, we care so much about privacy, and really we have all these like physical walls up there, and, you know, the privacy is that fundamental right. And I want to see that extended into blockchain in a transparent way, of course. And as Zack mentioned, ZK proofs are just one of the mediums there.
I'll add a spicy take here, just to keep things interesting. I think the idea that blockchains care about transparency is a false dogma. If you go back to 2014, blockchains were advertised not as transparent, but trustless. There was no talk about transparent. I think just because all the blockchains were public at the time, people just assumed the goal of a blockchain is to be transparent. I don't think any systems are meant to be transparent at all. It was just, that's the best cryptography could do at the time, and we are lucky now that we can do more. But to actually answer your question, most of the teams here work on ZK-based privacy, right? Am I right to assume that? Including Aztec. ZK does not allow you to do private shared state. So most of DeFi or things where people actually need transparency for will anyway happen on public land. The only place where you can have private shared state is like if you start using TEs. I know Zack called Aleo like the first programmable blockchain. I actually think that's not true. Like secret, Fala.
Programmable and private.
Secret and Fala are both programmable,
they do not have,
especially secret.
I mean, they do the computation in trusted execution environments, sure. But
Yeah.
then the fee that is paid is public. You can delegate that fee.
Sure,
It's
and-
not maths that is giving them privacy. It is that trusted environment, trusting Intel's hardware, right? So
Sure. So now we're talking about like, okay, what is private, what's not, right? So for example, last I checked, please correct me if I'm wrong, Aleo did not allow privacy for function call data, right? And then I can say, well, that's not privacy. That'll be false of me to say that because privacy is a spectrum. So I think it's unfair to call. By that logic, you can call Aleo as
you can see
public
what
as well.
is called. You can see this function has been called, but you cannot see if the transaction is fully private, because we
Yeah.
also allow someone to have certain public state,
Yeah.
certain private state. But if everything is private, you will just see a transfer was executed. You cannot see who, you cannot
Yeah.
see to whom, the balance. So,
Yeah, so that's the answer to transparency, right? You have a public state, and most things will go on in public state.
Okay, this is actually really interesting. So it kind of brought to light that we really don't, everyone has a different definition of what privacy is. So maybe like one of you can actually define it for our audience on what we're exactly talking about. What do we actually mean by privacy preserving blockchains?
I can take a gander. Privacy is basically, I think of it, if I do an action, like, think of it on the internet. If you send some data to someone, like on a messaging app, other people cannot see that message. Like if I send a message to Annie, other people cannot see that message. So by privacy, by default, only the people interacting can see the message. Everyone else cannot see. So by privacy, I mean what you're doing with a blockchain, or just what you're doing is hidden, right, by default.
So as I understand it, you have to choose what data you want to keep private, like that no one else can actually read the
I think it
message about.
should be the contrary. I think it should be you choose what you make public. By default, it should be private.
Oh, okay,
Yeah.
that's interesting. Cool. So we spoke about transparency in privacy-preserving blockchains, but scalability is also a big problem that it's generally there in Web3. Like we can't bring Web3 to the masses if we don't have scalability, right? So what, in your respective protocols, what compromises did you have to make? Do you think you have achieved scalability with privacy? Or do you think you had to make adjustments and some trade-offs? Maybe we can start with Rahul.
Yeah, so let's define all the different ways of scalability, right? So from the user's point of view, it's TPS. From the sequencer, validator point of view, it's like how many people, how many nodes can you have, how much bandwidth can they share with each other. Then there is like scalability from the data availability point of view. So I'll talk about the latter two first. Aztec will be a layer 2 on Ethereum. Ethereum has taken the approach that L1s are much harder to scale, and that's why you have L2s, vertical scalability. We use blobs. That's what gives us scalability for data availability. Yes, blobs are very minimal right now, but I think they're doing some great work to increase it with PRDAS to multiple megabytes a second. Otherwise, you also have EigenDA, Celestia, a bunch of really cool projects. And then on our nodes, we'll kind of have around like 5,000 to 6,000 node capacity using our proof of governance network that we'll have. The trade-offs there are you can create ZK proofs, but like they shouldn't be so big that nodes, when they're gossiping with each other, they can't gossip too much. The trade-off comes like, okay, can home stakers actually do this? I know Ethereum loves home stakers. Can we actually also do it? What's our RAM requirements? And then you get into some really fun engineering problems that I can go into detail about, but it's like, okay, how can we design our VM such that you have more columns, lesser rows, so you have lesser proof sizes, lesser bandwidth, on and on. And like you do those kinds of fun trade-offs to get to higher TPS or higher nodes.
Is there like a gold standard of what do you measure scalability in? Like what is good enough for scalability in privacy blockchain?
This is a hard question, like because so few companies have done this. There is no real gold standard, right? The gold standard is how best can you do. So you just keep pushing the limits. It never ends. It's kind of like a cat and mouse game. You put a product out, we take like how many ever years to build it. By then ZK advances, kill the product, new product, keep going on and on and on until you can actually compete with like, it's just an order of magnitude more than public blockchains.
Always room for improvement, right?
Always.
Anything to add?
Yeah, always room for improvement. Well said. In terms of scalability, it reminds me of this concept that the ZK researcher from the Soundness protocol had mentioned. he calls this concept continuous proofs. What he means by that is that he views someday in the near future that there will be proofs that are generated continuously, just like data. For example, data is generated continuously, it's overflowing. We as average humans, we generate, I think 2023 numbers were like 150 megabytes of data per person per minute. So this researcher feels the same way, where proofs are going to be generated pretty much every minute and multiple of them. So that could come from all the Web3 apps, DeFi, privacy. It could come from even Web2 and this budding area of Web4, which is AI and IoT. So for us at Horizen Labs, we believe that these continuous proofs will happen, they will proliferate, and we're attacking it from more like a holistic standpoint. There's this like proof value chain. You can attack it from proof generation, proof aggregation, and also proof verification. So we're building a blockchain that's solely focused on proof verification, specializing on it, all the different proof types that may come, that new, and we want to bring costs down and really keep up with the innovation frontier.
Adam, your point of view?
So how I see it is that in ZK scalability, I mean, there is inherent trade-off between scalability and latency or user delay. And on the other hand, latency is perhaps one of the biggest obstacles for ZK adoption. So like, why people are not using private actions so much? Well, because it's slow, because they need to download much more blockchain data, which takes time, and they need to generate proofs, which takes time, and sometimes even they need to wait for the proofs to aggregate, which also takes time. So it's just way less user-friendly. And then there is this trade-off between scalability and this delay. So like how we are approaching to it is that we don't scale more, we try to don't scale more than we actually need. So like we're trying to be as fast as possible right now. When we grow our user base to a point where it's actually unbearable anymore, then yes, we hope that solutions like, for example, Nebra or solutions for this aggregation, for creating recursive proofs will be mature enough that they can be just added on onto what we're doing. Yeah, I think right now, like from the get-go, most projects can reach the scalability of maybe 30 TPS, because this is all about proof verification on chain. So like with the new developments, like for example, Ref, the Rust-based EVM, I guess we can get it much higher without actually any changes in how we verify the proofs, because the gas limit can go just higher. So perhaps we can go like for free, we can have around 100 TPS. And like if we want to go above that, well, currently some trade-off needs to be done, and this trade-off will be with latency. So like as we're right now trying to mostly solve UX problems by fixing the proof generation time and doing a lot of this level optimizations, we don't go much into this scalability area yet.
Understood. Just a quick follow-up on that. I mean, the current non-Web3, non-private, like, I mean, you can say private, systems like Visa, MasterCard, they go up to like 30,000, 40,000 transactions per second, right? I mean, can we even get there? Is that like a number to even aspire to? Or how long do you think that it'll take to get there?
I mean, with the recursion, yes, I do think it's viable numbers to reach. I guess that would add, I don't know, 10, maybe 20 seconds to the waiting time by how this things looks now. And well, currently we have like together proof generation, on-chain action and verification done within maybe 3 seconds. So like for us, additional 10 seconds is a lot. Like from the user perspective, like no one has actually thousands of transactions per second in blockchain. I mean, I know there are some chains which are claiming that. I don't.
100,000 TPS to the moon. What are you saying?
Yeah, but I mean, like, but the real usage. When it comes to the real usage, I don't think there are chains with this kind of usage. And when it comes to the capabilities, well, like what people want to do on chain usually are smart contract interactions and not just the regular financial transfers. And when it comes to smart contract interactions, it's way harder to reach these numbers, like this thousands and thousands.
Could I interject? Okay, so if you compare apples to apples, right? So Visa level privacy on blockchains, how do we get there? Okay, so on Visa, transactions settle every 7 days. So you're looking at in blockchain lingo, that means block time is 7 days. You see it on your bank in 1 day. So pre-confirmation time is like 1 day, right? And on top of that, you have all of the validators can see everything, but the users cannot see anything. So you have encrypted mempools with 7 days block times with 1 day pre-confirmation. In blockchains, instead, we do 250 millisecond block time, 250 millisecond pre-confirmations with around 2 hours block time, let's say, roughly. L1s have it way, way faster. L2s, if I define block times as like the time to settle on L1, then you can average it out roughly to 2 hours. So like by that method, blockchains are already like at least 100x faster than Visa. If you want to compare exactly apples to apples.
That's really interesting. That's a good point of view. Often, like as users, we tend to miss. We see that like, the transactions happening immediately, but we don't really realize that they're not actually confirmed. Okay, so we spoke about scalability, transparency, but like when you actually start building privacy systems, you're kind of introducing a whole new vector of security attacks, right? I'm just curious to know more about like the breadth of what kind of attacks are possible in privacy systems. Zack, maybe you would like to take this.
I mean, I think, I don't know what like new vectors you're introducing, but as long as, given the system you're building is, for example, in our case, using zero-knowledge cryptography, if you have the validators verify that this proof is correct, the zero-knowledge proof generated, then you can trust the maths and that this has happened correctly, and then the technology of a distributed system of a blockchain that, hey, you're not printing money or you're not spending something twice. So I think no new vectors of attack in that case, as long as you can verify the zero-knowledge proof.
Well, you have attack vectors of the proving system.
So, if I can take, so I think not necessarily a vector, but there is new type of attack, which is invisible attack. I mean, it's very possible that a given ZK system will have a vulnerability which will allow attacker to mint new tokens without it getting noticed for years. So like someone knowing such an exploit can continuously exploit the protocol for years, minting new tokens, doing withdrawals, and if he's smart about it and is not exceeding some thresholds where it's becoming too obvious, well, he can, I guess, go away with it for quite a long time. And this is not only a theoretical scenario, this actually happened in 2018 with Zcash. So there was, this exploit was there on mainnet for, I think, at least 9 months. Just a handful of developers were working on fixing that. And, well, I mean, it's not clear, and it will never be known whether someone else knew about this exploit and whether it was actually utilized. I mean, it may be the case that we're living in a world where someone has basically infinite amount of Zcash tokens minted, but he's smart about it and just using them sparingly. And yeah, I mean, is it a new vector? I don't know, but like the old vectors of attack are getting way more dangerous. Regularly in DeFi, the very moment someone is using an exploit, it's kind of burned and everyone knows about it. Here it's very different. So I think like this situation is much more dangerous, and the audits are way more important than in non-ZK area.
You just need very good cryptographers, like we have at Aleo.
Yeah, I'll just add to that. It's true in terms of the verification of the proof and writing that verifier correctly. That's definitely an area of attack. There are new proving systems. They're like happening all the time now. Just coming back from ZK Summit 12, feel like there's yet another proving system, and there's like, I don't know, 12 new research papers per quarter. I think in writing these verifiers, they're often contracts on chain, and they need to exist and follow the protocol, the proving system that they're built for. For us at Horizen Labs, we want to build this blockchain solely focused on proof verification, where developers don't have to worry about writing a verifier. We would write that verifier for any new proof type, and then get it audited, and also make sure that it is written in a way that is very secure.
I think all privacy systems increase the attack vector by at least 10 to 100x. I agree with you there. You have the proving system that you're writing. The answer, like people who hate T's like to say, okay, yeah, you're trusting Intel, ZK is better. We say that too, for the record. But for ZK systems, you're trusting, is the proving system written correctly? There are like 300, 400 cryptographers in the whole world who can write this. Out of the 400, let's say 200 work in competitor companies. So there are like, you're left with 100 people in the whole world who can audit this. All of this is writing brand new cryptography that is never written or thought about before. There's bound to be a lot of bugs in every proving system, no matter how good you are. Bugs could be, in the proving system, could be under constraints, so you didn't write all of the assertions correctly. It could be in the verifier contract. It could be double spend issues, nullifier issues, the way you Merkleize state. Like, you take a normal blockchain, you have all of those issues, like if you do consensus, did you implement the consensus correctly? And then you have this additional problem of like, if an attack actually happens in private land, how do you even know that an attack happened? You then have a different problem. Did the attack happen at the app layer or at the protocol layer? Because you messed up with your protocol design. Then you have a third problem. If you figured out all of that, then how do you debug this? It's all private. Luckily, all privacy chains have this thing called an all privacy chains have this thing called a viewing key, which let you debug all of the encrypted data that has come to you. So at that point, you might have to share your viewing key with a security engineer who can help you work through your logs and see what happens. But even then, that's like really horrible. Ethereum has been used for over 10 years. The tools still suck. They're great, but they still suck. The only thing is we all have used them for so long, we know how to use them. New blockchains like Aztec, whatever, their tooling will suck even more, and it'll take a lot more work to figure out how to use it. So debuggability is something that actually scares me.
That's true. So what I'm hearing is there are bugs and attacks everywhere, but it's just more expensive in private chains because
Get the best cryptographer.
yeah,
They're still humans. They're still humans.
Okay, my next question is specifically for you, Zain, and maybe Adam, you can also chip in. So when you come to the business side, like privacy and compliance, like how does that work? So because you're dealing with so many geographical entities and they all have their own laws and regulations. So how do you bring privacy and compliance into the system, which is kind of global in nature?
So I think it's about future-proofing the protocol. I mean, right now, for vast majority of jurisdictions, there is nothing illegal with privacy protocols as they are, but like everyone knows, regulations are coming, so there are several ideas of how to make it more. It's not like how to make it compliant, because the protocols without these systems are not uncompliant right now, but how to make them future-proof. So I think there are two main ideas out there. The first one is based on the idea of proofs of innocence. So the idea here is that, like, when I'm using a given privacy system and I'm doing a withdrawal of funds from this system, for example, I go to either centralized exchange or maybe I'm just buying something, then I generate yet another ZK proof, and this proof should be the proof that, well, I'm not a criminal, basically. So what does it mean? That probably means that I never interacted with some list of addresses which are known to be malicious in some way. So there are several projects doing that. Here, unfortunately, there is a big problem because the list of these addresses, I mean, there needs to be some reasonable time frame for this list to get updated. And well, usually, unfortunately, the government's agencies which are doing stuff like that, they are not doing it within minutes or even hours. That takes days, if not weeks. So that would mean that if we want a system that works using this kind of proof of innocence, well, actually, it should have a delay of, I don't know, several weeks for users, because otherwise, I mean, it's very much probable that someone would launder the money there just by putting it and getting it out relatively quickly. Not too quickly for the privacy, but like also not months, but rather a week or so. So this is one of the ideas, which is, well, like ideologically very nice because it doesn't compromise privacy, but well, it can be argued that it may be not enough. The other idea is based on some way of non-voluntary revealing the trace of transactions. So on deploying some kind of a system which will be able to operate with a master key to reveal a certain user. So usually the pattern, the money laundering pattern that is seen is that there is some kind of a hack which is on public protocol, then the funds can be traced to some very particular transaction or set of transactions which are entering the privacy pool and the money are gone. So like then we can deploy the systems which, based on decision on the particular deposit, will reveal the trace that is left after these transactions. So this is what we're trying to do, where this system, we want to progressively decentralize the system to a committee, and then there will be a voting on which of these transactions should be revealed or not. This is one of the ideas. Generally, we are designing in a flexible enough way that we can add more system on top of it, as the situation is still pretty dynamic where it comes to what will be seen as a general standard. And yeah, I think this is a very much experimental area still. Like viewing keys is definitely something that is used by everyone for years. Right now it seems that it's probably not enough because it's purely voluntary, and well, it's enough that someone will deploy checks or other protocol that does not require showing the viewing key, and well, then it doesn't work. And actually the same argument goes for proofs of innocence. So yeah, I mean, I think we're gonna see. I've seen so far mostly these two branches of solutions.
Yeah, I think that's really interesting, the proof of innocence and this like proof that essentially captures the auditing trail. That's really cool. Yeah, in terms of compliance for Horizen, Horizen, right, being around since 2017, a home of the cryptocurrency Zain. Zain is available for trading in the main tier 1 exchanges, Binance and Coinbase. Last year, we were hit with a monitoring tag from Binance, and we were part of a group of privacy coins that were hit with that tag, and that kind of set up alarms for us. But in a way, the exchanges are this like, I don't know, they have this good, almost like pulse for regulation in a way. So we ended up removing the shielding feature from our blockchain. And we took that opportunity to say, hey, we want to build Horizen from the ground up. So we were a UTXO-based chain. and we want to move it to proof of stake, this substrate Rust-based chain, where first we'll start with specializing in that piece of the proof value chain, which is proof verification, and then we'll layer on other pieces of privacy after that.
That's very nice. We're kind of running over time right now, so I just want to hear some kind of closing remarks on you, any privacy myths you want to debug, or any message that you want to pass on to the community who are building on privacy blockchains. Just some closing remarks.
Yeah, well, anyone watching that wants to build a new application that makes use of privacy and blockchain technology, you can go to aleo.org right now and look at our developer documentation. We're live on mainnet. So you can build it in a week and deploy it and see what happens. Yeah.
So I can say that if anyone wants to build such a private application, focus on user experience, not on solving yet another academic challenge. And we've got a lot of people solving academic challenges, and definitely not enough projects with like reasonable use case on mind and a good user experience. So I think like right now, this is the biggest challenge in the industry, not pushing further the cryptography.
I think that more and more what I'm seeing is collaboration within the ZK space. I think there were a few projects that were very interesting. For example, collaborative snarks, which is combining snarks and MPC for proof generation. And then I think Zama is doing the snarks plus FHE, so that's private verifiable computation. And I think that these like new ways of doing snarks and proofs, they're just going to continue. And I'm really excited about all that.
Me too. Rahul?
Just say, privacy opens up a bunch of cool apps. Think dark pools, secret algorithms, private NFT marketplaces, uncollateralized lending. You can take TLS Notary, you can take ZK email and do crazy things with it. And I think if you're interested in privacy, rather than joining one of these amazing teams, build an app on any of these networks, but build apps. We need it massively.
I'd like to thank our amazing panel and for their great insights. It's clear that building privacy blockchains requires balancing complex factors like transparency, scalability, security, compliance. So yeah, it's a long journey ahead for us. Once again, please put your hands together for our amazing panel.
Thank you, thank you.
Thank you.
Thank you.
Thank you.